Welcome everyone. If you don't know me, my name is Andrew Evans. I'll do like a little bit more of an intro in a second, but basically what I'm going to be presenting to you today, I put together in a blog post. So everything I cover, I'll put this in the chat, but this link or this post has like code. It talks about how the project works. I have a couple of flowcharts, and then the project itself is I open sourced a version of it, and so you can go out and actually pull it down and play with it yourself, like after I do the presentation. But with that, I will go ahead and just start presenting. So I've got a little slide deck here, and if I can go view present. Hey, there we go. All right, cool. Okay, so again, my name is Andrew Evans, and today I'm going to talk about how I built a weather station with JavaScript. And this is actually a picture of Maine, which is kind of fun. And I was looking for kind of like a Misty Mountains look. So anyway, hope you enjoyed that. All right, so in my talk today, I'm going to talk about what motivated me for this project. I'm going to cover the project architecture, and the project consists of three big pieces, which is basically like an IoT sensor hooked up to a Raspberry Pi, Firebase, and then an Electron app that was originally a React app. And I'll talk more about that in a second. Once I cover these pieces, I'll do a live demo, actually showing you like what it looks like. And then I was also going to talk a little bit about how Electron works. So I'll do like a little thing with like how that's packaged. And then finally, I'm going to talk about some things I learned and open it for questions. Over here on the right, if I can go, there we go. Over here on the right, this is actually an image of the Electron app that I built that hooks up to the weather station. So a little precursor there. All right, so a little bit about me. I'm a manager at CapTech Consulting. I have 10 years of industry experience. I've worked full stack. Today, I'm primarily on the front end, but I have worked with Java, C#, and several back-end technologies in the past. I have a master's degree in computer science from Christopher Newport, and I have an MBA from William & Mary. And these are some fun pictures. This is me and my wife, and these are our fur babies. So why weather station? So I started this project because I'm a fan of weather. My wife grew up wanting to be a meteorologist, and we both are just kind of fascinated by weather. I've always thought it was cool because anything with weather directly impacts your life. You just you can't get away from it. It's right outside your door. So I wanted to originally do something fun with weather. This actually started back in 2020. This project that I'm showing you now is basically an improvement or an optimization of what the original project that I built. I wanted to use IoT also and connect basically hardware. During quarantine, I got kind of heavy into IoT just because I had time and I thought it was kind of cool. So I wanted to combine all these things into a project, and I wanted it to be something that was fun, but also something that I could use. So basically in 2020, I kind of hacked into this kind of Frankenstein thing. And this year it actually broke, which motivated me to rebuild it and then ultimately optimizing it. And what I'll show you now is basically the product of all that. So the project itself, as I said, you have three pieces. You have a Raspberry Pi, which is with the sensor. We have Firebase on the back end, and then we have an Electron app that is continually updating every 5 minutes. So what happens is the Raspberry Pi is hooked up to a sensor that's outside my window, actually. And what it does is it captures humidity and temperature. And then every 5 minutes that runs, captures that, and then sends it to Firebase. When Firebase gets it, I have Firebase functions that are, basically calling the Open Weather Map API, as well as some NOAA APIs to get additional weather information. And this includes things like barometric pressure, a detailed forecast, and then projected temperatures for the next, 12 hours or something like that. All of that is, so basically the sensor makes a reading, calls Firebase, Firebase does all that, and then it saves it. And it saves it in Firestore, which is Firebase's NoSQL database. Then separate from all this, the Electron app is continually polling the Firestore instance and pulling down the information. So in theory, as long as this runs every 5 minutes and this runs every 5 minutes, I get a full update. So before I dive into like code, I just wanted to show you what it actually looks like. So basically, this is a Raspberry Pi. This is right outside my window, and it's hooked up to, this is a DHT22 sensor. The sensor is housed in a 3D printed case. So like I printed to basically protect it from the weather and that kind of thing. But since it is outdoor, I had to open, there's like a mesh that's in front of it that I had to leave open. But anyway, that's the sensor itself, and that's running all the time. And then this is a computer on the left that I have hooked up in my office, which has the weather, my little Electron app running that's polling and getting the information from Firestore. And then this is the National Weather Service's radar. Now, this is publicly accessible, like NOAA is publicly accessible in general, but this is cool because it automatically updates. So basically, I leave this running on 24 hours a day, and I have a full weather forecast ready to go, including radar. So I thought that was kind of cool. There's like a couple ways that I could have done this in code as far as like wrapping a radar setup, but because you know, this auto updates and this looked kind of cool, it was pretty simple once I got everything else hooked up, I just left it, you know, to be. But that's kind of what it's going to look like when we're finished. So the Raspberry Pi, and this is the sensor outside of the housing. This is what I was talking about, where I have like kind of the little holes here so the air can get to it. But basically, this sensor sits inside here, and then that's what's hooked up, you know, on the outside of the window. So the Raspberry Pi, what the Raspberry Pi does is pretty simple. It basically, I'm using the Adafruit libraries to interact with this sensor. All that's open source, free. It's in my, I think there's a link in my blog post about it. And basically, you just it just talks to the sensor and then does a reading. And so you see right here, you know, and this is all in Python, but it's all just a basic, you know, grabs the temperature, builds a body, and then makes post requests to my Firebase API. And then obviously I have like catches for errors, and then I do a little logging. I'm not really going to go into that much with this because this is more focused on JavaScript, but this just shows you that with just a little bit of Python, you can do a lot. And Adafruit makes it really simple because they have helper libraries for a lot of different like IoT functions. And so, you know, with just this little bit of code, I could kick off the whole process that gives me my weather station. So basically, moving from the Raspberry Pi to Firebase, in Firebase, I have a serverless function, and this is actually, there's a way that you can host, you basically, with Firebase, you have functions which run internally in Google Cloud, and then you also have the ability to create an Express serverless API. So basically, this is serverless. It uses Express to like build out your endpoints. And with just a little bit of code, you have like a full-fledged API, basically. This is the endpoint that the sensor makes the post to. And if you notice, it goes and calls NOAA, which is like in this function that I've created, and then it calls the Open Weather Map API. And I'll show that in just a second. But basically, it's making HTTP calls to both of those places, parsing the data, and then returning. And ultimately, this is the payload that gets saved. So we have information about temperature, humidity, a detailed forecast, your hourly forecast, barometric pressure, wind speed, and the like. The reason that I bring up JSON Web Tokens is because, so my current client, I'm a consultant with CapTech, my current client is doing a lot with JSON Web Tokens. And when I was working on this project, we were pretty heavy in like the development phase of using JSON Web Tokens. And so it was kind of fun because I actually got to use some of the things I was learning at work on this. And basically, what I did with JSON Web Tokens was I wanted to make sure that every step of this flow was encrypted. So I want to make sure that, you know, the connection with Firebase, it's, you know, end-to-end encryption. The connection with my front-end project, it's, you know, encrypted. So what I did was the Python code that I wrote packages, and I think it's actually in, or it might not be. Yeah, it's not, because this is just headers. So I don't have the, I'll show you that in just a minute. But basically, the Python code injects a token with like a secret, and then that's what makes the API call. And then inside the Firebase API endpoints, I have middleware right here that is validating the token. So any endpoint I have for my Firebase API, this is happening in the background whenever the API gets called. So this isn't that much code, and this just shows you like kind of the power of one, JavaScript, and two, honestly, Firebase. Firebase makes things very simple with the way that they've implemented things, and it's easy to get up and running, pretty quick. So basically, as far as Firebase goes for this project, we have an endpoint, it's receiving a post, we're grabbing all the data and then saving it. And every time a request is made to Firebase, it's using this validation function to then verify, the value. And then if it's not, somebody's trying to make this like a hacker trying to make the API call, it's going to return a 403. So the last part of this was the front end. So I've got the sensor is recording data, it's sending it to Firebase. Firebase is doing the storage of the weather data. Now I needed like a front end to be able to show everything. I originally started with the React project, and originally actually it was hosted with Firebase. So like I told you, my first version of this project, I just used their hosting service. It was very simple, it's all out there. With this one, because I was using the JSON web tokens, and also because I had just recently started learning a little bit about Electron, I thought it would be fun to actually build this with Electron rather than just React. So in this case, what I did was I took the React project and I repackaged it with Electron. Electron, if you're not familiar with it, is essentially a building tool that allows you to create desktop apps with JavaScript. So you can take your JavaScript and you can, write some great like front end thing, and then Electron will package it and you can send it to like iOS, or you can send it to Windows, or any of these environments. But you use parts. There's an Electron builder which will package it. There's also, I think, Electron packager. But all these things culminate in basically you taking what should be a front end project and then creating a deliverable that's in the form of something that can run on a desktop. So it's a really cool technology. And it was great for this use case because I was able to take essentially what I'd already built and then package it so I could run it as a standalone app. So ready for the demo. All right, so I'll see if I can hit escape. There we go. All right, so this is the project. Basically, what I've done with the project is, if you notice, I've got weather page, I've got the weather sensor, and then I've got the weather server. So the weather page is the Electron app. The sensor is the Raspberry Pi code. And so if you notice right here, this is the try catch that I was just showing you, a minute ago. And then I've also got like a couple other scripts that basically clean up my Raspberry Pi. I've got one that deletes logs because I don't want to Raspberry Pis are very limited in space, and I didn't want to basically eat up memory. And then the Adafruit library is cool because they have basically, you can just copy and paste this test program, and this will pull in your Adafruit, and then you can actually test the sensor hooked up. So this is how you can verify that everything is working once you got everything else set up on the Raspberry Pi. So that's the sensor. With the server, we have the what you would normally see with a Express.js API. So basically, we have you're pulling in Express, you're pulling in in this case I've got an env file. And then I'm using Axios for API calls. But this is all basically just packaging the Express app, which then I have these middleware functions, which I'm using. And then I'll get back to these in just a second. And ultimately, I have my post endpoint, and then I also have a get endpoint. So the post endpoint is what I showed you in the slide. This is what's actually writing the values out of Firestore. And then the get endpoint is what's retrieving it from Firestore. The post endpoint also makes the calls to the Open Weather Map API and NOAA in these two functions. And this is basically, this is NOAA. So NOAA is pretty straightforward because the National Weather Service has a maintained API that is pretty reliable. Sometimes it fails, but like in general, it's free. It's really a great way to track your weather. But basically I call that, and that's kind of all that is. And that's just like parsing the values. Now, when you get to the Open Weather Map API, Open Weather Map API is actually, it's European, but they have data internationally, across the globe. And so what you can do is you can get, I think like a developer or an individual actually has a free account, and then they have like paid accounts and that kind of stuff. But basically I call that, and then I get to use actually a little bit of trig here, because the value for wind direction comes back in degrees. And so what I'm doing here is I'm basically just using a Cartesian plane to figure out what direction, north, south, east, and west. And then for barometric pressure, the Weather Channel had this nice little post that explains like how to calculate barometric pressure. And in this case, what was happening is I think this is a standard I forgot what HPA is, but like it's the unit of the barometric pressure. So I had to do this math to basically create the accurate number to match what you get from, weatherchannel.com and that kind of stuff. So anyway, once all this is here, that's the response, and that's what's returned. So this is basically the server. And finally, we have our weather page, which is our Electron app. So this app is basically, it's a standard Create React app. I'm using local state. I'm not using a Redux or anything fancy. The one thing that I am using that's kind of fancy is if you look at the calls, I have this thing called retrieve weather, which is using RxJS. So if you're not familiar with JavaScript or really like RxJS, RxJS is reactive extensions for JavaScript. It's very popular, very widely used in the Angular community, and I think it's kind of getting more prevalent in the other kind of frameworks. But basically what it does is it creates the idea of a stream. So instead of doing promises where we do everything like as individual actions, what RxJS does is it just listens. So you create listeners, or what they call observables, which then receive messages, and it handles that. So what I'm doing here is I'm using their interval operator, and what this does is it creates a listener which will then poll at a specified time in seconds, and then it gets all the information. So that's how I'm continually polling. I could have also done this with like a basic loop or a dozen other things, but this was nice because it kind of packages it for me, and I got a chance to use RxJS. So so that's basically the app. And then like as far as the actual Electron-ish kind of things, I talk about it in my blog post, but basically like I had to add like a home page. I also had to add like a build parameter right here, and then these are some npm scripts that basically allow me to run the app locally, and then Electron Pack actually uses Electron Builder to create the deliverable that I was talking about before. And then the other thing is that I think I had to do something else. I think I just had to install, I had to install Electron on my machine and Electron Builder. So, but that's basically the page. So I will show you this actually running. So if we do Electron dev, so what this is doing is it's starting up the React app, but then it's running it through Electron. That's why it's using concurrently, which is it's an npm package that does this. And basically now you see I have a little progress bar, it's updating, and this is live data. So this is actually being pulled directly from the Firebase API. And what I have here is I have the temperature, I have wind, humidity, and then I have barometric pressure. And right now it's blue because we're in a high. When it goes low, it turns red. And then I have basically essentially 4 units of time with the National Weather Service. So they usually have the current, like if it's the daytime, the daytime, the nighttime, the next night and day, or sometimes it's fun because they actually pull in holidays. So for like 4th of July, it'll say like 4th of July and that kind of thing. But anyway, this is all data that's coming directly from the National Weather Service, and it gives me an idea of what the weather is going to look like, not only today, but for the next couple of days. I also have, I used recharts, which allows me to chart basically the projected temperature for the next 12 hours, which is kind of cool. And then finally, I have indicators as to whether the sensor that I have pulling in my temperature and humidity is successful. NOAA, whether the API call is successful, and then the open weather map, if that's successful. What I have this coded to do is basically it saves the last state. So basically, like if one of these fails, it'll just keep what was already there. But then as long as these work, it'll update the values. So this is nice because like the sensor will go back, like the sensor will have errors a couple times a day. And so this allows me to maintain my weather, because I mean, you know, 5 to 10 minutes of time, your weather isn't going to change that much. So like I was fine with, you know, that amount of error or whatnot. But that's basically the front end. And this is, as you see, this is like an actual, you know, like I'm on a Windows computer right now, and this is this is a executable. And now I've lost there it is. Okay, this is an executable that is running on my machine. And then you have like all, you know, the cool part with Electron is that you have also have a manifest. So like I could actually take and build in like behaviors. So like what I have here, this is just like the dummy, you know, basics. But basically, like if you wanted to have something special in these like dialogues, you could actually code that in this little file. All this is all in my blog post as well. But this just shows you that like with just a little bit of JavaScript, you end up with this like really cool desktop app. So that's been a lot of fun. And then the last thing too was that just to show you Firebase. If you're not familiar with Firebase, Firebase has like pre-provisioned database hosting, you know, authentication and storage. They also have like some more advanced stuff with like machine learning and that kind of thing. But basically, this is my Firestore instance, and this is essentially the collection, and this is the data that's being saved. And I was just showing you like that's what this looks like. And so with that, I will jump back into my presentation. So let's go present. Okay. All right. So what I learned along the way. So basically oh wait, I forgot about this. Hold on, sorry. I want to show you something cool. So basically, if you notice with the, when I was running the app locally, you know, I'm using the Electron dev, but I also have this thing called Electron pack. So what this does is this is using Electron Builder to package the React app as an Electron app. And I've already, you know, gone through this, but I'm running this because I want to show you like actually what this looks like. So basically when this, when it finishes there, it will create, and you see it's running the Electron Builder script. And when it finishes, it will create the deliverables, which in this case is an exe file. So this exe file is what I could use to install on a computer. So you can basically copy paste this, and you can install it as a program on, you know, your Windows computer. For iOS, it'd be like I think a .app file. For Linux, I can't remember, but like basically this is the packaged stuff that you can then, you know, deliver to your customer and whatnot. And this is, I ran this before, which is why these files are still here. Now it's just taking a second. So it'll take a minute to run. So I'm just gonna let that go. But if I go back to present, now I can talk about it. So the things that I learned along the way with this project was that hardware does take time. I can guarantee if you're new to hardware or IoT, it's probably going to be about double whatever you would expect it to take to build a project, because you have to learn how to actually like literally physically like connect things, and then you have to learn how to deal with them in code. So I would just if you're going to do this, I would give yourself plenty of time to be able to learn. When working with JSON Web Tokens, I ran into a big problem where the Python code that I wrote was actually basically encoding a string as bytes, and when Express received it, it didn't know what to do. And so there's actually like a method with Python that will encode it with Unicode, and basically I had to use that. And the long story short is it's only like a one-liner. I can even show you that in my project. And basically this took me like a couple hours to figure out, because I could not figure out why it was doing that. So we have, there it is, decode. So if you call this, what it does is it takes the JWT that's been created, and then it puts it into a format that can then be input as a string, which then can be put into Express. Like if you don't do this, then anything that consumes the bearer token you're creating won't know what to do with it. So anyway, I found this, I think it was on a GitHub issue. Somebody explained how to do this because somebody else was having the same problem, but this took a long time. So I would just air caution when you get into things like that, because if you're not, super familiar with the language or the paradigm that you're working in, that you have issues like that. Additionally, when packaging your Electron app, what I learned was that you really need to build your app on the operating system you want to deploy. So basically, if you look at the Electron documentation, if you look at Electron Builder, what they say is that you build on any device for any device. But what I found was that if I tried to build for like an exe file for Windows on a Mac, it didn't work. The file would be in like the wrong format. It would say .exe, but then when I would try to install it, it wouldn't know what to do with it. So what I learned was that basically, if I want to build on a Windows machine, I need to for a Windows machine, I need to build on a Windows machine. So I use both the Mac and Windows regularly for different things. And I had done most of this on a Mac. And basically, when it got to this part, I had all these problems, and so I ended up having to copy the project over to my Windows computer, run it, and then I was able to package it, in the way that it would work. I've heard some people, I haven't done any research in this, but I've heard people say that there are build tools that will do this. So you could actually use a CI/CD platform to actually do this. So then you can have, you won't have this problem. It's just me running this on a machine that I own. So like, obviously I had this issue, but in a corporate or a more professional context, I would imagine you would probably use like a runner or like a CI/CD, tool of some kind that would do this. The other thing is that there's a lot of blogs and packaging React with Electron. If you Google, let me package my React app with Electron, you're going to find a ton of information. The problem is that everybody does it a little bit differently. Not to say that they're wrong. It's just that basically they did it to match, like the manifest file I was just talking about. They added things to, match what they need or whatever. I had a lot of problems with this because I just wanted something to work. So my recommendation would be, if you're looking to do this, find an example that works and then try to use that as the basis for your React project. So with that, I will open it up to questions. I can stop sharing. There we go. All right.
All right. So thank you very much, Andrew. So yeah, you can either ask the question directly or you can post it on chat if you're feeling a little shy. That's fine. So any questions?
Yeah, I was curious if you could say a little more about the JWT tokens, like how you use those, and like what do you get in terms of the end-to-end encryption by doing that?
Right. Yeah. So the big thing was that I wanted to, the first version of this project was completely open. Like I didn't have any protection on any endpoints, and I just kind of left it that way because I mean it's just weather and I didn't really care. This time around, like I said, because I was using it on the client side, I wanted to get to play with technology a little bit and actually do it. So the whole point was I was trying to basically make sure that the only person that can actually receive the API call or can interact with anything in the system would be secure. Otherwise, I didn't want other people being able to get to my stuff basically. And so what the whole purpose of using JSON Web Tokens is really just to basically generate the bearer token that the Firebase API then takes and decodes to figure out what's going on. And then the same thing with when I make the GET call from the Electron app, it's doing the same thing. Does that make sense?
Yeah, totally. Sounds cool.
Yeah, I was really surprised because JSON Web Tokens are like really easy. Like, and the other thing that I thought was really neat too is that the Electron, I mean not Electron, the JavaScript npm package I used, and then the Python npm package. I mean, not Python doesn't use npm. The Python package that I was using and the JavaScript package that I was using, they use the same algorithm. So I thought it was really neat because you had two different languages that you're able to interact with, and all on the trust of the standard, which is, you know, it's just, I just thought it was cool. So I mean, a lot of people probably be like, oh, that's fine, but you know, standards really make the world go around. So
definitely. Any other questions? So while we wait, the hardware part of it, like you had briefly mentioned there, that like it's difficult, you know, or at least it's going to be time consuming. So like, did you, with the libraries that you used from Adafruit and all those, like, did you, like once you had got the hardware set up, like how difficult or easy, like what did you feel about like using the software, so the software side of it?
yeah, once I had it set up, it wasn't hard at all, because it's very like, you know, once you get because the great part was Adafruit is that they have like a bunch of different test programs that you can run. So like I'm using a DHT22 sensor. There's also a DHT11, which is a little bit cheaper. It's not as reliable. They have different libraries for both. And so like, and they also do this with, I think it's Beagle Black. There's like a couple other like hardware, you know, IoT platforms that they use. But basically like you, you know, you just install those packages on, you know, whatever the device you're running, and then they give you all the code. So Adafruit really like made it easy because, but the reason that I was saying that it would take time and it was hard was because like, so the first time I did this, I was new. I had to solder wires. Like to do this, I basically soldered wires for the actual sensor itself to the jumper wires that are connected to the Raspberry Pi. That's not that hard, and that's pretty simple. It's just a little bit of solder and two wires. What I had to do before that was actually mount the GPIO headers on the Raspberry Pi, which is, they're basically the pins that you hook up. To do that, you have to do like a bunch of little teeny, you know, joints for all of the little pins. Anyway, I didn't know what I was doing, and I just put like a huge glob of solder, and it looked terrible. And I was just like, well, I mean, it's just, you know, metal to metal, and I don't know why this doesn't work. Nothing worked. And what I ended up finding was that it's called solder bridge. And you're also, I was kind of embarrassed because it just looked terrible. So, you know, mental moment, you know, I should have realized if it looks terrible, it probably is terrible. But you know, beyond that, like I cleaned it up, and then everything was able to work and whatever. But that's what I'm saying. Like you run into stuff like that all the time. The other things are like what I've had with specifically, like going back to what you're asking Sujith with the libraries. You know, there's like little intricacies or whatever you want to call them, like within the different functions that they use. And you know, the thing that I was talking about with the web tokens, that's a very, very basic Python concept to just decode something into UTF-8. And I don't work with Python every day, so like I didn't think about it, and I didn't realize that, you know, I had to do that. So it's like you plan for it, and you have these like tutorials you're following, and you're like, okay, this is how this is going to work, and blah blah blah. And when you actually get down to it, a lot of times you end up having to learn something you didn't plan for, I guess. And I think that's like kind of, which is fun. I mean, it's not, you know, like I do this kind of stuff like all the time. And the reason I keep coming back is because it's still fun. It's just, it's like, if, you know, say you look at it and you're like, oh, this will be a Sunday afternoon. That's probably not going to happen unless it's like, you know, you're turning a light on, or like something like super simple. Yeah, you're like making a sound or something, like, okay, that's, you know. But if you're actually building a full-fledged, you know, thing, that's going to take you like a while. So
yeah, but I think one of the cool things is like when I was when I was in college back in several decades ago, I guess.
Last year.
It's like you had to like get really low level libraries or assembly language or something like that to like interface with hardware. But whereas like it looks like now we can just use Python, which is a pretty high level language. The libraries can directly interact with the hardware that way. I think that part of it is really cool. I think that just opens it up, because yeah, otherwise, like, I mean, on top of all that, like also having to debug assembler and stuff, like it's not difficult, but like it's not something people do every day. Yeah, definitely having Python as the interface is I
Yeah,
think.
exactly. I was just going to say that I feel the same way. When I was in college, the same time you were, actually, we had all of this stuff was new. You know, the Raspberry Pi Foundation hadn't really gotten that far, and like, you know, like the idea of IoT was still like really exciting, but the people that were doing it were like literally writing like assembly, or like, you know, it was like physical transistors and that kind of stuff. And so it's nice because now all this is like obfuscated, and like, you know, kids can do it, which is the reason one of the reasons the Raspberry Pi Foundation is so great, you know, in my opinion, because like you have a whole generation of people that are learning, and, you know, having fun. And I mean, like, you know, I wish I'd had this when I was a kid, you know. Yeah. But I think I was going to show you, let me share my screen. So this is the Adafruit library that I was talking about. And so they have a learn, you know, page, and I'll put this in the chat. And basically, this shows you how to hook up like with like a breadboard and then like a device. And this is like Circuit Python, and you can run this. Basically, installing Circuit Python on the Raspberry Pi is how, you know, I'm able to connect with Circuit Python. Is just like the name for a big thing. You can also get Circuit Python devices. But anyway, they have all this stuff. They have, you know, your test program. It shows you like these are literally like the pins on the board that you're supposed to hook up to. So like P8, 11, D18, and then you know, they have like other tutorials as well. But like the point is that this is all you really needed to do to get started, and then from there it's just like running like install programs and then like interacting with the device and that kind of stuff. So it's really well documented. So I think that's like just a really cool thing.
Yeah, definitely. I think yeah, I've heard good things about those.
Yeah, they seem to be like, I think they just seem to have the market for this. I mean, it's like, because I know like Raspberry Pi has a lot of tutorials, and like there's a guy, it's a couple, I think, they build stuff, and they have I forgot what I had to use them one time, but like in general, Adafruit I think has the most like information. So
Oh, thank you.
yeah, and I'm gonna post links to my project, and then if I can get my blog post up here.
So yeah, so anybody else have questions? I mean, I have one more or a couple more, but I want to give everyone a chance. Okay. So on the other side of the things with the Electron app that you mentioned, Andrew, so does it come? I mean, I have not done anything with Electron, except I know that I think the Slack app, I think, is an Electron app, and maybe VS Code is.
I think VS Code is too. Yeah, right.
So does that come with its own like UI library, and or like how does the UI part of it work to kind of give like a native look and feel? Did you have to?
Yeah. So I think I can answer your question. Let me share a screen again. So I did a project some time ago where I wanted to create a Connect 4 app, and I think it's still running, but it's been a long time since I did this. I did this back in 2019. So like basically like I talk about like Electron. So this is so if you don't use a framework and you don't do like what I'm doing, this is basically what you end up with. You have a package JSON file, you have like a main file, which is essentially like your entry point, that your app uses, and then you have like a web page, and your main file, all it does is it pulls an Electron, and then you've got like create your window, and then this is essentially creating like a browser window, which will then be packaged as like an executable or whatever. Then the web page interacts with that. So like I've got, in this case, this one was using like the version of Node and Chrome and Electron. So this is like real hello world stuff. But basically, at the end of the day, if you just want to use Electron by itself, this is like kind of where you start. The cool part with it is that because Electron is using JavaScript, you can basically use like React, Angular, Vue to create an Electron app. And what that will do is it will just use this same process, but it'll use those frameworks, building tools to create the JavaScript bundle. And then the bundle is then pulled into, like your HTML file. And I talk about that, I think, down a little bit further. So this is like the final bundle looks like this. And so like this is before being packaged, and then this is like I think after being, or maybe not, I can't remember. Okay, I'm losing you. Anyway, the point is that what you do with like the super simple setup where all you had was these 3 files, you're then like with the changes that I was talking about, where I added like a home page, and then I added a build command, and then I have the Electron like manifest file that's like giving you like what that window will look like. All of this is pulling in, and you notice right here it's using from the build. So like if you do React, if you do like create React app build, it'll create a build for your project, and this is like your front end project. So what this is doing is it's telling Electron to use that generated like JavaScript bundle, and then create a desktop app from that. Does that make sense, Sujit? Okay, cool. Yeah.
So you are pulling down the so when you do like you're pulling down the assets from the library, from Electron itself. Okay. Yeah.
The Electron is basically just like a package kind of thing, and you're just telling it where to pull the assets and like where to pull the bundle, and then and so you can leverage all the build tools that you do with front end, and then you just say, Electron, I want you to use this, and then it does that. And then when you come into Electron Builder, which is the tool that I was talking about, what that will do is then it uses what you've coded with like the Electron setup to then generate the actual like deliverables. And then Electron Builder has like a site too, which I should have like, here, I'll just share my screen one more time. If you go to Electron, and they also have Electron Packager, I think. I've used Builder more, but there's a whole set of documentation. There's like a whole way that you can you can install it, and then there's like these are like your dummy default settings. And then there's like very specific ones where like if you're creating a DMG file, there's parameters you have to set up. But this is how you create the deliverable from your JavaScript project. So
awesome.
Yeah, I'll put this in there too.
I'm pretty sure you can even sign your app so it says it comes from a registered developer.
Yeah, that's right. Yeah, you can get like, I think you can get it to the point where you could actually send it to like the App Store or Google Play Store once you've done everything. And that's why, honestly too, that this is such like a useful technology, because you think about like if you have a team of people that have only done front end or only know JavaScript, they can leverage this, and then all of a sudden they're full stack. Because they're able to like do everything. I mean, I know, just I'm there, but like, the point is that like it gives them a chance, and so if you're on like a tight deadline, or like you just don't have the talent to do what the client needs you to do, you can leverage these tools to get around some of the issues. So
Yeah, definitely. I think, yeah, if you want to build like a more desktop app with the same code base that you have with your web app, I think definitely, I think this is the way to go.
Right. Yeah.
The older solutions are pretty heavyweight, and you really need to know what you're doing with, like, say, if you want to use like Swing or JavaFX or yeah.
Right. I mean, and you don't, and then you, well, and then if like if you wanted to use like iOS, you have to use like Xcode, and then you have to like pull in, you know, like there's a whole like set of things you have to do for that. And so the nice part is that this will kind of bypass that, and you're not having to rewrite the same code for like 4 different platform kind of thing. So
cool.
Yep.
So we kind of, people are dropping. So any questions, Robbie, Wyatt, Chuba? If you have any questions?
No, thanks for presenting. I'm gonna go place my order for a sensor.
yeah, good. You should yeah, you can get them on Amazon. They're like super cheap.
Yeah.
Yeah, do it, man. It's fun. I
So I have an interesting problem that I've been trying to figure out how. So we have a cat that we let, right now, like we do need to install a cat door so that she can get out. But now we haven't installed it yet. So we just open the door like and let her out, and then she can come back in when she's done. So the problem I'm trying to solve is like, I need a way to know that she's going out and that she's back into the garage, because then I don't have to go in the yard looking for her. So especially because it's getting darker earlier and earlier, so sometimes we let her out and we are like, oh shoot, like, is she back in or no? We don't know. So I was like, what can I use there to kind of, but I don't want to put anything on her if possible. Like I don't want to put, unless it's very light, like like if it's like a really simple sensor, like what's that called?
Like an RFID chip.
Yeah, like an RFID chip. Maybe that might fly, but we don't want to put anything heavy on her. So
yeah, I mean, I would just like, if I was going to do that, you can get like motion sensors. Like there's like lots of different, I mean, you could probably, honestly, you might be able to find something on Amazon that somebody's created, but like,
yeah, I mean, they have it, like, and in fact, we even had one of those around, but she doesn't like it. Like she doesn't like the heavyweight stuff. So we need something like really small, like really lightweight and simple. So
yeah, well then like the RFID chip would probably be good. Or if you could get like, I think there might be like a solar powered kind of thing that would be able, or sometimes they have like, I mean, this is like, I haven't done any research in this, but I've heard of like kinetic devices. So like as they move, it charges the device. So like you might be able to like look into that's a really cool, if you do that, like you need to share, like I want to see how you do it, because what I would do, like if it was my cat, like I would probably just like right outside the door, I would have like a motion sensor, and then I would have it like set up to like call it or something, and then
that's the first thing I thought of. But the problem is we need to know when she's going out versus when she's coming back in, right? So we need a way of differentiating, because she does it several times when we leave the door open.
Right.
But
I know they have like contact sensors. Like my garage, I have a I have a Wi-Fi remote thing set up, and it's a contact sensor. And so like when the garage door closes, like it knows that the two are connected to each other. So maybe if you could set up something like that on the cat door, then you would know like when the cat door is like going open and closing. And then you're not even doing motion sensing, because at that point you're just like literally listening for like the
then I just count the number of times, so I know that if it's even odd, she's gone out. If it's even, she's back in.
Right. Yeah. See, you're on something. The funny part was, like, for me with the garage, when I got it, like I was super excited because it has this notification feature. But the problem is that it's like cheap. Like, I mean, I think I got it on like Prime Day or something. Anyway, sends you way too many notifications. Like the door will close and you'll get like 4. It's like door's closed, door's closed. I'm like, I don't need to know that.
Yeah.
And then it got me like really scared because like I didn't know when I had actually closed the door. And so now like I turned all that off and I just use it like if I'm gonna like go for like a walk or something, and I like if I just want to close a garage door, you know, like I can do it. But I always make sure I look that the door's closed, you know. And I have this whole thing like set up idea that I had in my head to have like essentially a video camera that would take a picture every time, you know, and I don't know. I just don't have enough time to work on that right now. But that's anyway.
Yeah, I mean, I was even like keep it very simple. Like I was just going to like have it where it would have a green light, like 2 LEDs, like a green and a red or something like that. So that way, like I can just look over there, and if it is red, I know she's out. If it's green, I know she's in back in. Because when she gets back in, she hides too. So sometimes you don't know if she's really back in or not. So anyway, I'll let you know. So maybe on Prime Day or Black Friday, I'll see if things go on sale that I can pick up.
Yeah, I mean, I know they make a lot of stuff like that now. But if you wanted to like, you know, do it yourself, they have there's a lot of tutorials and stuff you can do.
Yeah, it was more just like you. Like I was like, yeah, you could probably buy a weather station online for like, you know, like $100 or something, but you wanted to scratch your itch. So I mean, the same thing here.
Yeah, and that's what I was gonna say. Like the best part about doing this project is like you just learn so much. Like you don't realize you're gonna learn. I mean, it's not always the most fun thing, but it's like when you finish, you're like, wow, I learned all these things, you know. Like and that's why I was saying like that's another reason why I was saying it takes time. You just gotta be patient, you know. That's the big thing. So but
cool,
Ian.
All right, thank you everyone for staying till the end here. And once I get the video down, I'll slightly edit it and put it up, and I'll share the links. So thank you once again, Andrew. And we can plan something for the next year. So we can talk about that. So
yeah, sounds good. Thank you for letting me present. This was fun.
It's always a pleasure.
Yeah, I don't get to come to all the meetups because I get like busy or whatever, but I like this group a lot, and you definitely do a solid job with everything.
Cool. And maybe we at some point in the spring we may even be able to have an in-person event, but we'll see how things develop.
Yeah.
Cool. All right, everyone. Thank you so much, and have a good rest of the week.
All right. Bye, guys.
All
Thanks,
right.
y'all.
Bye.
All right, I'll see.